Okay, now on the bench we have this Something and Smith Manufacturing Company fan that looks like it's been through the ringer and back a few times. The customer did take it apart, start working on it, and that's okay. And then he decided he didn't want to take the risk. But it all looks bent out of shape, don't it? I don't know. Yeah, that definitely doesn't look like it's rounded right, but we'll deal with it. Um, so, and here's the front part of the front of that. Yeah, see, this is round. This should be round too. I don't know what happened there. Might have got tousled in the mail, but we will fix that. The blade is definitely bent. A couple of them. We'll try to fix that too. I got to run it through and wire brush and take all this stuff off this blade anyway. That paint don't belong there. So first thing to do is get the blade off, and then we'll take a look at the electrical, which obviously leaves a lot to be desired. And the switch. Switch doesn't seem like it's any good actually. It's really loose. Was it? No, because the screw's turning. I don't know. Maybe it's clicking, so who knows? We'll find out, right? Get some tape on the body here that I've been pulling off, some old tape. But let me go ahead and pull this blade off and we'll start looking at the motor first. That's the most important. And see what we can find. Be right back. Okay, I got the propeller off and cut the wire here because that needs to go. And connected my digital meter to the stator wires here, and we're getting 19.9 ohms. And you'll notice that as I turn the motor shaft, you see what happens. That's a good sign. That means the armature and the stator are interacting with each other. It was locked up, but I got it freed. I didn't put no oil in it yet. I'm going to put some oil in it. I'm going to give it some voltage and see what happens. See if we can get it to turn. If we can get it to turn, that's a good starting point. So let me get set up for that and we will do that test. Okay, I got it connected to my limited power supply here, current limiting with the light bulb, and it's a Variac. So I get the light bulb on. If there's a short, if I just short those leads together, the light will light. That's the only thing that'll happen. So there's no danger of me dealing with it, even though I got a suicide cord plugged in to the unit here. So let's bring the voltage up and see if we can get anything out of it. Not going to go up too high till I see what we got. Okay, right now I'm at 40 volts, roughly, and we're drawing 350 milliamps. That's a lot of current, so 8 watts at 41 volts. See if it's even, yeah, I feel some humming. Hear that? That's a good sign. Let's bring it up a little more. Now, some of that wattage that we were just looking at is that bulb, which is going to draw a lot of amps. Okay, so, but the fan itself is drawing 430 milliamps at 12 watts. Okay, and we're only at 48 volts. And we'll bring it up a little more. You notice the light's getting brighter. It's brighter in the phone than it is here. But that's okay. I did put a little oil in here, so nothing's binding. It's wanting to turn, but it's not turning. It's like the magnetic field is fighting itself. That's what you hear, that humming. And that's why it's drawing so much current, 500.5 amps. Still not a lot, but 17 watts. Okay, I'm going to bring the voltage down a little bit and shut the light off, which will put all the voltage to the fan. And we're at 31 watts. And it's still not turning. Okay, so we got to figure out why it's not spinning, but it is tight. It's really tight. This fan hasn't been run in a while. I might have to just take the case apart to clean it before I can even go any further. Yeah, because it's hard to turn. You see how it turns and stops? All right, that's not good. So, I got this loose, so it's not the, I don't think it's the, I don't think it's trying to oscillate there. What's that, a E-clip? Oh wow, no, that's actually smashed on there with a cast iron rivet of some kind, just smashed on. You don't take that off. Okay, I see how that goes. And that's coming through here. It connects here. Oh, it's got a screw on this side. Okay, let's get the screw out. Turn it around. Make sure that it's not binding, trying to oscillate. And I might need both hands to get that screw out of there. Yep, I'm going to have to get the screw out and I'll be right back. Okay, that mechanism is going to take some time to get off, so rather than mess with that, I just took the whole gear assembly out of the gearbox. So now the motor is no longer even connected to the gearbox. We're working on the motor. You know, you got to pick your enemies, and the motor is the enemy at this point. Still a little bit tight to turn, but it's turning better. I'm going to try it again. Give it some voltage. Still don't want to turn. It's grabbing instead of trying to turn. Which is strange. It should be spinning. Maybe this motor has a capacitor. Let me check that off. Make sure there's no capacitor in the base. Some motors have a stock capacitor, and this is feeling like it could, but I've never seen such a small fan with a stock capacitor, but who knows? Let me check it out. No, it doesn't have a stock capacitor. It does have a speed coil, and that plate was on there, and I just unscrewed it, took it off. This is the speed coil, and it has two speeds. It has two coils in here, and then the third speed is a direct. Something in there. Is a direct line like I'm doing. And it tells me that it's supposed to be 0.85 amps. So that, if that is the correct label, yeah, that goes around to the other side. 110 volts, 0.85 amps. And it has the model number there. So that's good to know. And it looks like, does that say Brazil? No, it's a number, 71238. My eyes are not the greatest. Okay, well, we're not worried about the speed coil just yet. I'll check it, but right now all we're worried about is getting the motor going. So let me set this back up, and I think I can do it with one hand or two hands. Okay, so the speed coil is back under there. Let's try it again. I don't want to short anything, but this wire is insulated. This coil wire in here, see, you have to scrape it to actually get a connection on it. So it really can't short unless it's already shorted. If it's already burnt and shorted, then yeah, they could touch. But for right now, I'm not going to worry about it. The wire's all deteriorated. Let me just shove some insulation up there. Okay. See, it's turning pretty freely. It should spin. Let's try bringing the voltage up a little higher. Stuff jumping off my cabinet. So now I know what the current should be. We're already past it. No, it's locking up. It's like it's trying to turn it both ways at once, which is an inconsistency in the magnetic fields. They're actually, the way it's supposed to work, let me shut this down so we don't, okay, the way it's supposed to work is the stator creates a magnetic field in one direction. The armature gets magnetized by the magnetic field going through, and it has grooves in the armature that direct the magnetic field in the opposite direction, and well, actually in the same direction as the magnetic flux from the coil, and the two magnetic fields repel, right? And that's what spins the armature. Some armatures work that way. Most armatures probably work the opposite. Same technology. It doesn't really matter how you look at it, but you know, the magnetic field would be going around, and the armature would try to follow it because it would be opposite poles, and they attract. And so that's how armatures work in these kind of fans. The armature does not have brushes, does not have coils. It's in bushings that it spins in, but this one's turning easy. I'm going to have to open the case in order to find out if there's something fluky going on inside the unit. I don't see any problem in there. It looks pretty good. I was hoping we could get it to spin before we took it apart and cleaned it, but we may not be able to. Let me go ahead and get this old seal out of here. It's just a retainer ring. What we want to do is just simplify things, you know, just keep simplifying it, make it easier and easier for that armature to turn till we find out what's causing it not to turn. Once we get that, then right now it's turning fine. A whole lot better than it was. It's still not spinning like it should, but you know, it's old and hasn't been running a while. All right, shut the power completely down because I'm going to lay it on its back, put some oil down in that shaft. Let me go ahead and do that, and we'll try that. Okay, we have a motor. All I did was, the case was a little bit open, but I went ahead and oiled it from here, and I squished that a little bit better. But that wasn't the problem because it's not turning any better than it was. But you see, I'm only on 56 volts, and that motor's spinning. And we're drawing 0.34 amps, which equates to 10 watts. 0.34, it's rated at 0.8. So we're fine. We can bring the voltage up. Let's bring the voltage up. Okay. We're about 95 volts. That's about right. I'll go a little more. Okay, we're close to 110. All right, 105. 110 is what it's rated at. So let's get it to about 110, somewhere around there, and see what we got. 0.7, 34 watts. So at 110, it should be around 0.8. Okay, there's 195. Yeah, we're fine. Motor sounds good. Plenty of torque. Can't stop it. Can't touch this. Okay, so we'll clean it up, and we're on our way to recovery. We'll check the field coil next, make sure that the speed coil is good. We'll check the switch, make sure the switch is good, and then we'll start wiring it back together. Then we got to deal with the mechanical, you know, the blade and things like that. I don't paint because I don't have a paint shop, so I would let the customer know that if they want to paint it, they're going to have to take care of that. But we do the electrical restore, and I definitely can do the mechanical And this is a disaster here. We'll get it fixed so it's nice and neat, and we'll get all this old paint off and try to clean up this blade. Originally it should have been, I would imagine originally this was aluminum colored. It's aluminum, and I think somebody painted it, and so the paint's just flaking off. I can't believe that that would be factory and flaking like that. That would indicate a very bad paint job. See, even around where there's no wear. You can see what, see, I just rub it with my fingernail and it comes right off. So I'm thinking this was rattle can painted. That's what it looks like. So we'll get rid of that and sand it down a little bit, try to give it a little bit of shine, make it look better, but we got to straighten out the fins. They're definitely bad. But that sounds good. So there we have the first video on this fan. And I'm going to stop the video here because it's not too long, but a little bit long. And just to go over again what we're going to do, fix the propeller, service the motor, take it apart, redo the head wires, run a new head wire down at the bottom, run a new cord, and get rid of this 50s, 60s cord that don't belong on here. Well, not that cord, but this cord that doesn't belong. Get rid of this 50s, 60s cord. It's got to go. Yeah, look at that, it's all rusted. That's got to go. So we'll put a nice plug on there, a nice cord. And I ground them so the chassis will be grounded. You know, that way if you plug it in, you don't have to worry. Like, see, back in the day, they didn't have ground plugs, they didn't have polarized plugs. So you could plug this in either way. Well, your neutral in your circuit box goes to earth ground. It's at the transformer. There's a post right into the ground, and the neutral connects to ground. So if you plug this in with the hot wire going one way or neutral going the other way, and you turn it around and put it in one way, turn it around the other way, whatever, there's always a possibility of an internal short on one of the wires to the case. And if it's the hot wire and you touch it, you're going to get a shock, and it could be dangerous if it's, you know, bad, you're in water or touching a pipe or whatever. So I put a polarized plug just for added safety. Actually, I put a 3-prong plug. And I take the ground plug, which is the same as the neutral, by the way, like we said. Take the ground plug and I connect it to the case, just like modern equipment today. It's all grounded to the case. That way, if there's ever a short, it'll trip the breaker. It'll never give you hot voltage on the unit where you can touch it and get a shock because you're standing in water or touching a grounded pipe or something. But this sounds good. For day one, for start, this is really good. Good sign. So we're on our way. Thanks for watching the video, and be sure to check back, like it, hit that bell, and you'll get updates as we add new videos to our channel. And check the description, because I always update the description with links to the following videos. So this is video 1. When I put out video 2, just the description in video 1 will have I'll add a link to it to video 2, and in video 2 I add a link back to video 1 so people can find the first video. And I do that. If I got 5 videos, I have 5 links, so you can go right to where you need to be, or to start over, or to see one part that you want to see again. Now, you know, if you're working on these, just be really careful. You know, I know what I'm doing. I have a variac. I have a limited bulb if I need it. I have a watt meter, amp meter. I know that these wires here that look like they could touch each other in, you know, World War II. No, these wires are coil wires, and they're covered in shellac. Unless the shellac's worn, like there's a spot there where it is worn, both of them would have to be worn, and then they touch, and then you got a short. That's how coils short out. The shellac wears away, and they touch each other. Of course, if you touch that connector or that connector, or bump them with your hand, you're going to get a shock. You know, this is suicide here. If that touches the chassis and the wrong one of these touches the chassis, again, it's going to spark. I have a fuse in there, low amp fuse, so it'll blow. but still you could get a serious shock. So if you're working on these, you're doing this at your own risk. Understand that. I'm just here to teach you how to do it. Use that. You people that are following me, and I'm trying to teach you how to do this stuff. But I take a lot of risk because I know what I'm doing. It's not because I'm sloppy. It's because I've got the experience. So if you're working on these, take your time. Make sure you know what you're doing. Don't do stuff like this. If you don't have the experience, don't do it, because you need to know what you're doing. You need to be able to look at a copper wire and know, is it safe? Is it not safe? What's the issue with it? These things are important. Anyway, thanks for watching the video. Enough of my ranting. And please give it a thumbs up if you found it informative. Have a great day.